G'day and welcome to the Off-Chain Podcast. Don here with you. Our guest today is Bayley Wang, CEO and co-founder of Prisma X, the robotics and intelligence platform working towards building the AI ecosystem for fully autonomous robots. Really pumped to talk with Bayley about the intersection of AI and robotics, challenges of physical AI, and why visual data and scaling is what's holding back robotics from working with humanity for the greater good. It is going to be a very interesting conversation. They're building something very unique and interesting. So let's dive in. Tell us about your origin story. How did you get interested in robotics? You can wind back the clock.
Yeah, so I've been doing research in robotics for over a decade now. Back in 2012, when I was an undergrad at MIT, I had the pleasure of working with the team that did the DARPA Robotics Challenge for MIT. So we worked with one of the first dynamic humanoids, one of a very early Atlas prototype to do the challenge. And that challenge really highlighted a lot of the issues surrounding hardware at the time. When the hardware did show up, it was chaos. There was 15 different robots. There was one that just looked like a coat rack full of wires, one that was basically literally a coat rack. And then I went on to work on the Mini Cheetah project at MIT, and that was sort of transformative because it made the hardware a lot sleeker. It applied existing supply chains for things like drone motors in order to make the actuators much cheaper. And that sort of ushered in the current era of robotics, where you see a lot of really sleek machines, and shifted the focus of the industry more towards task completion and intelligence. And that's really important for advanced robotics. Outside of 6 degree of freedom, 7 degree of freedom robot arms for manufacturing lines, robots haven't really seen a huge amount of success in commercial use cases. And I think a lot of the reason for that really is a lack of competent software to make them tick and make them user-friendly. So that sort of segues into what we're doing right now at Prisma X. We're helping give these machines the intelligence they need to work in the real world and really hit mainstream adoption.
Yeah, man. So has robotics been kind of linear progression, or have there been a couple of big leaps over the years? I mean, obviously at the moment we're thinking about, for a popular level, from my perspective, kind of looking at it from the sidelines, I think it appears that robotics has really made huge leaps and bounds recently, but has that just been all happening in the background already, or is this really a new era for robotics?
There was a sort of quantum leap on the hardware side in 2018. Everyone all at once, and I think the MIT project helped a lot, but it was certainly other people contributed as well. Everyone all at once converged on this electric drive, what they call quasi-direct drive hardware actuator. And there are a lot of benefits in not only the controllability of those robots, but in manufacturing costs and integration complexity as well. And that made it a lot easier for people to build the robots. This is why you see so many robots right now. Then secondarily, I'd say in about 2023, 2023 was the inception of a couple of prominently venture-funded projects doing sort of LLMs, but for robotics, what they call embodied intelligence or physical intelligence. And I think that drove a lot of VC interest because of a couple of really prominent investments in the space, right? Physical intelligence raised $400 million from Bezos Expeditions. 1X raised a couple $100 million from their VCs, and that drove a lot of interest from the business side as well. Which is why there's a lot of folks taking advantage of the opportunity to try to really build something impactful in the space.
Yeah. So you mentioned the kind of the AI integration with physical robotics or physical AI importance, for robotics, and in particular what you're working on at Prisma X. Why is that so important for mass adoption? Has it been, you kind of insinuated that's been the missing link. There's been a couple of, quantum leaps in terms of the physical hardware and whatnot, but in terms of actual mass adoption, the software has been the lagging element. Why is physical AI important for robotics, and what does that even mean?
I think by physical AI, we mean broadly generalizable physical AI that can be controlled using methods that are intuitive to ordinary non-technical people, right? Fundamentally, it's sort of a UX problem, in the same way that ChatGPT being able to generate Python doesn't necessarily make programs better or Python better. In fact, you could argue the quality of the code is definitely going down. But it makes it a lot more accessible to people who are not highly experienced. I think it's the same thing for robotics. You could go buy a pair of 7 Degree of Freedom robot arms right now, set them in your kitchen, and then write a bunch of programs in like some like Visual Basic style language to get the arms to cook eggs or make sandwiches. But this is not a very pleasant workflow, and it really limits the interest of people in adopting the technology. The idea behind what we're calling physical AI or embodied AI is you'll be able to interact with the system in a much, I would say, looser way, being able to use things like natural language or point where you want the robot to go and have the robot follow those instructions. And I think that ushers in sort of a new era of interactions with the machines, which almost everyone agrees is very important.
Yeah, man, it's been the promise since the Jetsons, right? Or even before that of the future for us. We didn't even really talk about what is even a robot. So are we talking about drones? Are we talking about the little vacuum cleaner that rolls around my living room? Are we talking about, I consider my car to be a robot. It drives itself. I can just jump in and press a button and away it goes. What do you mean when we're talking about robots?
I think the current industry means by what they mean by robot is anything which is more complex than simply a moving platform. Like, you're right, drones and cars and vacuum cleaners are all robots, but the only sort of like mechanical aspect is they have a way to move around, right? So I think marketing wise, they mean anything more complex than that. And I think specifically, robot to a lot of folks in the AI native robotics industry means 2 arms on some sort of mobile platform, like two human-like arms with some way to pick things up, some sort of gripper on some manner a mobile platform. It could be a wheeled base. It could be as simple as you pushed it around. It could be a pair of legs if you want to do something which is fully humanoid.
Yeah, so I mean, part of the earlier robots that I can recall seeing in media have been on like car production lines, which are exactly like you say. They just look like humanoid arms. They're doing things, and the promise of like 2 little robot arms doing microsurgeries and things like this seems to be kind of that's been part of the the promise or the hope that at some stage in the future we'll be able to have that, but at a much more popular or retail level even. But obviously, there are mammoth applications in industry and military and I mean, everywhere really. My question is, you mentioned AI has been like the missing link. Is this just like you just pop an LLM onto 2 robotic arms and away you go? Or are we talking about something more bespoke and nuanced? Are we talking about not really LLM at all? How do you think about what are you thinking about when it comes to applying artificial intelligence to robotics?
The industry has sort of converged on what they call a VLA, a vision language action model in some way, shape, or form, where you basically the idea is this: you have a robot and you have some set of instructions the robot needs to complete, and the robot's got some sensors. So from the sensors, the robot will gather all the things that's currently happened to it in its current environment. And then the goal of the model is to go predict the next chunk of actions, like the next second worth of things the robot needs to do. And it does so by using a combination of an LLM and what they call a action head, which is a small diffusion model. So as I was saying, the model goes and generates these actions using a combination of a language model type architecture to go decode the images and the instructions, and a diffusion model to actually generate those actions. So then what happens is the model says, hey, robot, I think over the next second, you should go take these actions. The robot then takes like some of those actions. It takes maybe the next 10th of seconds of actions. The model once again looks at the surroundings, assesses the state, and then repeats for the next second. It's this idea of predicting future action across a horizon is very powerful because it gives you sort of a smoothing action over the next second or 2 seconds of activity and makes the model a little more robust to noise. It's common across all modern robotics. It's how the traditional robot dogs and robot humanoids walk. And it seems to be the way that we want to go teach robots how to do tasks as well.
Is that computationally demanding? Like, does that happen at device level, or do they need to be hooked into some sort of powerful computer somewhere else?
It's an interesting question. There's a lot of hope that we can make it happen on the device on the device side. I'm not so optimistic about that because the model does need to be incredibly powerful. It needs to have a complete visual understanding of everything that can happen in the world. And to me, going and fitting that on a single robot with like a reasonable budget is hard. So I think it's going to have to happen server side, but I don't know. There's cost isn't really an issue here because Nvidia makes 15x margins on its hardware right now. So there's a lot of money to be saved there, but things like power consumption are real problems, right? You can't have the computer be drawing 5 horsepower in your robot. Among other things, your house will get very hot if there's thousands of watts being put out by the robot just to think.
Yeah, interesting. All right. So is this something that you're thinking, if we're talking about, say, a home or household, you just have one central server running all of your applications, running all your bots, or still somewhere, in a large data center somewhere that's just connected by the internet? Or is there some hope that, there'll be advancements in power production or energy production that might actually work better at device level?
The problem with it's not so much the power consumption as the fact that all the waste heat needs to be removed. And that gets out of hand if you're putting out, like a space heater is about 1,000 watts. If you're putting out 3 space heaters in your robot, it doesn't matter how good the robot is because the space you're in is now no longer usable by the humans, right? And the way semiconductors are going, the heat problem cannot be solved. We lost what's called debtor scaling a few years ago. So technology advancements in semiconductors don't make the GPUs put out less heat right now. I think it's going to be either remotely, like maybe having an on-premise server which gets plumbed into plant water if you're an industrial plant, or if you're a household, doing some, probably going to be in the cloud, probably going to be cloud inference. And there's going to be technologies that run on the robot to pick up the second or so of latency from the cloud.
So how are you doing? Like, what are you doing in robotics and AI? What's Prisma X's vision? How are you participating in, or even helping push that vision forward?
So we're one of the many AI native robotics companies, and we're one of, I'd say, 4 or 5 serious crypto plus robotics companies. Our focus really is on scaling the human operations behind robotics. There's a lot of robotics companies that are either tackling the hardware first or tackling the model architecture first. But to us, it doesn't matter how beautiful of a robot you build or how good of a model you write in PyTorch, right? You're gonna need things like training data and distribution and maintenance and reliability and teleoperation. And that's actually a much harder problem than the technology, because you can get 10 smart people in a room and they can sort of cheat out good robot designs, and you can get 10x engineers to go write good models. But if you need 10,000 people to go operate on your platform and make the robots actually tick, it's going to be very hard to, there's no free lunch there. Like, humans are humans, and human labor is like real value. You can't have a smart person solve that. So we're leveraging decentralization and cleverly crafted mechanisms to make the human fleets behind robots self-organize. Ultimately, the goal is, of course, to be able to do things like collect the data and drive the distribution necessary to meet mainstream adoption. But also, once the industry takes off, to be able to support the millions or tens or hundreds of millions of robots that are out in the field with our fleets of trained and experienced operators that can make sure that the robots are doing the thing they're supposed to do in the real world.
Yeah. I mean, that's a massive vision. And you must have a massive, or at least a massively competent team to be pulling something like that off. Lots of people have been trying to get AI and robotics to work. Lots of people have been trying to get AI and crypto to work. And you have gone for the trifecta of crypto, AI, and robotics. How does the crypto aspect actually form part of what you're doing with PrismaX?
I think crypto is really valuable here. I think one of the reasons why the other crypto plus AI projects are sort of not as successful as they want to be is because they're not leveraging the strongest aspect of crypto. And to us, the strongest aspect of crypto is its ability to engage humans and drive emergent behavior out of communities, which you could not get in isolation, right? Like, once you add a little bit of incentives or rewards or scores or leaderboards to the mix, 1 million people suddenly become a very smart superorganism. And with the right mechanisms, you can cause that organism to do incredible things that no single person can do. And I think that's that's where the crypto really comes in. It provides a transparent way to score, incentivize, record the reputations of all of the people in the community, and in doing so, drives engagement and drives emergent behavior, which ultimately make the platform much better. Compare that to, say, some of the other AI plus crypto projects where, like, decentralized inference is a popular one, right? But if you think about it, if you're successful, people will build mining farms to mine token. What's a mining farm? It's just another data center. Ergo, you reinvented the data center, but slowly and somewhat poorly. And it's just unclear how this is actually better than centralized. And there's like some security things, but a lot of the projects aren't really going down that route right now. So I think being able to coordinate humans as the resources is really valuable. And I would say it's the same on the robotic side as well, right? If you look at early computer vision, the single most successful company out of the, I'd say, 2015 to 2019 AI wave was Scale, which did Scale build no models. They built no technology. Their magic was they figured out how to go coordinate 100,000 people in the Philippines and turn them into a Python API. And we're sort of trying to replicate that, I would say, emergent behavior. It's the same thing. You have people, they want to get paid, they want to earn, and from that, they'll self-optimize to do what you want if you build the right mechanisms.
So you're saying there are people and projects that are trying to abstract the human element, but you're going the opposite direction. You're saying, how do we integrate these things, actually get a better outcome?
Yeah. The people are all the people. The data sure is something that we accrue to the network, and it's value, and we can be sold to multiple customers. But ultimately, I think that the community is really what provides strength and value to our project, because you can't replace these people, right? You can try to synthesize data, you can scrape it off the internet, but when you do need to interact with a real human to do teleoperation or make sure the robots are doing the right thing, that's a real human, and it needs to be a human. And if you assume that AI models are optimistically going to be 90% accurate in the wild, that means for every 10 robots, you're going to need a person to make sure that robot is doing the right thing and stepping in when there's an edge case. So that's a lot of people on the platform doing work on the long run. To 10 million robots in the wild, 1 million people.
Yeah. Man, you got me thinking. Okay, so the end user, or the goal, is it's better for people. And so people using robots with AI that is supported to create intelligence by humans. And so there's this kind of cyclic, I'm just trying to think how it's different to, say, in the vision of the Matrix, where you have humans being batteries for robots, and the robots, the artificial intelligence, they're the net beneficiaries of the human output. But we have human output making AI robotics better, making humans better. Is that the point?
Yeah. The robots are tools, right? In the end, a robot is, because robots are somewhat biomimetic, people think of them differently, but really it's just a tool. And in like science and industry, robot arms are not robot arms. They're 6 degree of freedom positioning mechanisms. And their goal is to take something and place it in space accurately. So it's the same thing. Like, effectively, if one guy is driving 10 robots, that means he now does 10 times as much work. And if you believe that work is worth some amount of money, he can now not only earn more, but do so from the comfort of his own home, rather than having to go out and like lift heavy objects in order to make that money. So it's good for everyone. And the more efficient the machines get, the more each single person can get done, the more valuable they become. And I think any reasonable person believes that society will advance and will need more labor and need more work done. Like, it's not like we're capped out on the amount of work that can get done. There's all this talk of labor shortages, manufacturing shortages, skilled labor shortages. So I think that kind of amplification is just overall very good for humanity. It's really no different than, say, like, we invented the electric motor and now one man can drill 1,000 holes in a day instead of 10, right? It didn't destroy the contracting industry. It didn't make manufacturing. It didn't make construction go away. But the people who worked there became a lot happier because they now had access to technology to make their lives easy.
Yeah. So one of the fears of AI over the last 3 or 4 years has been, it's going to replace my job. It's going to destroy, human flourishing and meaning by taking away our productivity or creativity, and What you're saying is actually, no, it's going to amplify our ability to do all those things.
Yeah. Automation is a good tool to make people do more and make people do more of what they're good at. Like if you can automate it, it basically means the task was very repetitive or there's a lot of data on it already. So it's ergo no longer truly creative. And it's the same in content creation, right? By providing tools to make editing images and masking objects easier, you can let the artists focus on actually being creative rather than painting over the subpixels and the edges of their mask in order to Photoshop their images. And I think that's important. And there are some nuances around attribution and payment and but overall, I think once the industry sorts out the financials, and blockchain could help there too. There's a lot of interesting projects that are trying to do things like IP attribution. I think once the industry sorts that out, it'll be very good.
How does a token, speaking of blockchain, how does a token help for scaling autonomous robots in the real world?
In general, having a floating value native token allows people to invest in the progression of the robotics industry by joining early to say make robots accessible, or joining early to do teleoperation work in order to collect training data. They now have a piece of stake in the growth of the industry, which I think mirrors the current situation quite well, right? Where robots, because they're not very commercially viable, it's hard to say get 1,000 robots in the wild and make them be able to be teleoperated. But if you can provide those incentive mechanisms and you can say, oh, we will incentivize you in something which is potentially worth a lot more in the future, that drives attention to the project. It sort of kickstart adoption. If it were like a more mature industry, I would argue that you wouldn't need a floating token. You could have like a stablecoin type payout mechanism, and it's sort of the same thing. It's still a just transparent proxy for recording value, but there you no longer need to float the value because the value is well known ahead of time. Like I would argue if you were, say, providing GPUs as a service, the value per hour of a GPU is extremely well known, and there's no reason to let that price float.
Yes, gotcha.
But I think for robotics, it makes a lot of sense because it mirrors the growth of the industry, and I think people are going to be joining in order right now, especially people are going to be joining in order to have a stake in the future and be part of something which they think might be bigger.
When you say creating the future, is that just a progression, iterative or linear progression over time? Or is there some sort of future vision you have where you'll think, oh, this is the milestone, maybe not the goal, but at least the milestone that I call the future? Do you have that vision for what it looks like when it comes to robotics and how we as humans interact with robots?
Yeah. So I think I call it the GPT-3 moment or the ChatGPT moment, where the models suddenly scale big enough that their behavior changes. And once that behavior changes, they suddenly become reliable enough through scaling and generalizing the training data and the model sizes to really enable new forms of interaction with the systems. And that's the moment when robotics is really going to hit mainstream adoption, right? The people were working on natural language processing for 10 years trying to translate English to French, and no one cared. But suddenly ChatGPT came and the model grew big enough that you could talk to it. And it wasn't like they sized ChatGPT in a way anticipating this conversation application. They discovered after the fact that this model could talk. Like if you showed it a bunch of data of people talking, the model itself would learn how to mimic that behavior. And that was a transformative moment because it enabled a whole new paradigm of interaction with the technology, which, as it turns out, is extremely user-friendly.
What's the timeline from here to there with regard to robotics?
I think reasonable amounts of generalization for things like light industry and commercial and restaurants and hotels is going to happen in the next 3 years, with some applications coming out in 18 months for more specific verticals. I think enough generalization to do domestic robotics is feeling like a 5 to 10 year timeline right now. And it may sound long, but it's just important to remain realistic, right? It's really bad for frontier industries when people overpromise and underdeliver. So I think just keeping in mind there is something really freaking cool at the other end, but it'll take some time to get there, is just important. So I've been saying five to 10 years right now. I've heard some people be more on the 10 side. At least one large venture funded company said 8 months ago, Well, I think it was 8 months ago for teleoperated robots in the home, and currently they're not in the homes yet. So you see what happens when you overpromise.
Yeah. I mean, how could you possibly, like you said before, even with Chat 3, they didn't know until afterwards. How could they project forward and say, well, publish this task? And
No data on the scale required, right? Like you can't go out and say like in 12 months I will ship this product. Like that's full of crap.
when you say 5-10 years, retail or in a home, are you talking about the classic, again, Jetsons style humanoid robot walking around doing the dishes, cooking dinner, cleaning up, that kind of stuff? Is that what you're talking about?
I think it's probably going to start with laundry, cooking, and maybe some light cleaning work. There's sort of a debate right now as to whether you need a fully legged robot for domestic applications. And it's a very annoying question because domestic is a capex sensitive market, right? There's like spending money upfront means a lot for home users, and they have no clear ROI for the purchase. So the problem with legs is a leg costs roughly as much as 2 arms. It's like the same number of joints, but the motors are bigger. So you roughly triple the cost of the hardware to add the legs. And there's a reliability problem. Like legs are very complex to control. There's a little more points of failure. So if you assume that legs won't necessarily make it into the home market for quite some time, you have to ask yourself, what can I do in a home with just wheels? And look at those killer applications. And maybe that's something like cleaning your living room or cooking or just doing laundry or folding your clothes in a more fixed setup. Bit hard to say right now. Everyone wants to have the fully legged robots in the home like the Jetsons, but I think there's some real engineering issues behind the dream.
Actually, wasn't the Jetsons on a wheel? I can't remember.
The Jetsons had like an AI first house where it's really annoying. If you look at a typical residential house, there are these random 4-inch steps that are built in for like visual reasons to delineate the separation between like the family roof and the kitchen, right? Like it has no reason being there. It doesn't add functionality to the home, but god damn it, it makes designing robots for homes hard.
Do you think that will change how we design homes? If we start getting robots on wheels, we'll start designing them for...
I really hope so. We're already seeing a little bit of like technology forwardness in new constructions and homes, right? Things like mostly better kitchens, cleaner kitchens. Smart home was a big thing. Thinking ahead for things like wiring for TVs and internet. And I think it's not that big of a sacrifice to say the first and second floors don't have steps inside them.
Interesting.
I don't think that makes your house much worse. It's just not something that people think about right now.
Yeah, right. Well, so you've given us a timeline. What needs to happen between now and then?
I think for the full domestic dream, we need to collect an unreasonable amount of data. It's one of the things that our project will do moving forwards is scale data collection to very large scale, like more domestic organic efforts beyond just things like fixed scenario teleoperation. It needs to collect a lot of data so that the resulting models are as robust as ChatGPT. ChatGPT is sometimes wrong, but it very rarely outputs complete nonsense. Like modern language models see enough during training that there's rarely something they can't at least hallucinate a plausible result to. And I think the analogy in robotics is the difference between putting the dishes on the wrong shelf versus taking the dish and like placing it in the trash or dropping it on the ground or like fleeing it across the room. Like, you don't want that kind of chaotic, horrible scenario happening in the physical world. You want like more soft errors, and you need enough data so that you can sort of be able to understand and detect when these things might happen. And I think on the hardware side, it's fairly clear, as everyone says, we need to get the cost of the hardware down to in the 10 to 15,000 range before people will even consider it.
Yeah. Yeah, man, you just reminded me of like when electric vehicles started becoming more mainstream and more common, the news articles were every time that one would catch on fire, which was still fairly rare, it became out, oh, here we go, here's a new technology that's failing us. And you have a couple of things that are really strong outliers that even might still happen with normal internal combustion engine, or the existing technology might have the same kind of outcomes. But people become very suspicious and fearful of these kinds of things as well. And obviously there may be, political undertones to those things, but I'm just wondering, how are you feeling about the pressure on the robotics industry to have to nail it? Because like you say, if it's the difference between putting a dish on the bottom rack rather than the top rack, that's a small deal. If it's smashing it on the ground and injuring somebody, that's a massive story. Well,
I think
there's
that
like no margin for error at that, at the level of causing harm, unless they're intentionally for that. We might get onto military applications in a bit, but in the home, obviously, you want to have that kind of. Is there a margin of error that you think that you're kind of thinking through at an industry level?
the expectations need to be set right. I think I'm not going to say that the robots will ever hit three nines of reliability, but I think part of it is having humans in the loop in order to step in when there's uncertainty. I think part of that is setting the allow applications and expectations correctly, like not starting with applications where you could cause harm. Definitely not starting with things like using sharp objects or taking care of your children. Like these are not the kind of failures you want to have in the field. I think it's a little better for robotics than for EVs. There's like this deeply entrenched fear of lithium ion batteries in society, which is caused by some weird incidents in the 90s, I think, related to airplanes. And like the FAA is very twitchy about these things because it needs to achieve like 8 nines of accuracy, or otherwise the airline industry will fall apart. Plus, there was a lot of commercial pressure to make EVs not succeed from incumbent energy companies, which is kind of weird because their like non-renewable resources are used to generate electricity as well. So I don't see what the fight is. The electricity comes from somewhere. But for robotics, I think there's definitely going to be a lot of embracing by the entire sort of business world, because it's new streams of revenue. It makes things more efficient. It opens up new opportunities. So I think the only back pressure is going to come from sort of regions that are very technology resistant for whatever reason, simply because it's priced too high or they don't understand it. I saw some alarming posts on X the other day from some public figures about how states should be allowed to ban AI in order to protect jobs, which to me is ridiculous. It's like saying states should be allowed to ban power drills so that they have to pay more to have people drill holes. Like, what's your end game here, right? Your end game is irrelevance. Like, come on, guys, this is not reasonable.
Yeah, I mean, speaking of unintended consequences, I heard that is one of the ones that you might see on the on the political side, where you go, man, if you ban something that has already proliferated, it's already out in the open, all you're going to do is drive innovation and usage and the proverbial 10xing of productivity outside of your jurisdiction. It seems absolutely foolish to do that kind of thing, especially now. Like the horse is bolted, figuratively speaking. What about the unintended consequences of robotics and AI? How much time do you spend kind of philosophically crystal balling about the future and unintended consequences?
I think we're going to have some precedents set pretty soon where teleoperated robots cause some damage, either a criminal or civil, and we're going to have to sort out the chain of liability and responsibility there. To me, the responsibility clearly lies with the teleoperator. Like, they were the one behind the scenes driving the robot, but it's going to be interesting to build a system which handles that well. And I think that's sort of the concern with these autonomous machines as a whole, right? Autonomous driving has a lot of trouble taking off here in the US because just push came to shove, they were unable to find someone to blame in case of an accident. And because our system requires that accidents have someone to blame, our conclusion was simply to not have autonomous cars, which is kind of unfortunate. But for robotics, the accidents are going to be smaller, and any like real damage is probably going to be intentional and teleoperated if you design the system with some thought in mind. Like, not having the robot pick up anything sharp is a good start.
Yeah.
I don't really want robots running around with knives right now. I don't think the AI is reliable enough. Like, is it a cake or is it you?
Well, so a lot of, like we mentioned before, a lot of AI and robotics companies in particular are trying to remove the human element to remove human error. and you remove human error, we kind of, that's been at least as long as I've been alive, that's been one of the kind of driving forces, I think, behind a lot of computers, maybe mathematics computers. How do you remove the human emotion, the human element that makes mistakes when code is king, or code doesn't make mistakes, or maths works, and that becomes the scaffolding, on which you might build an entire platform. But the flip side of that is we've had a lot of, at least popular media and public thinkers, talk about the proverbial Skynet of Terminator and the rise of machines and the Matrix and all these kinds of, at least the popular imagination level. There is still an underlying kind of fear that, man, if I have this thing in my house, or if I'm driving around in this robot or machine, somebody else can hack into it. And, people don't tend to really understand hacking or, how that works. But add in a human element or a to actually operating or participating in the operation, and then we're actually inserting the human element for error once again. And so I'm trying to think, how do you balance out that? How do we make the perfect system with, how do we make something flawless on the one side, but that's not just a self-derivative drop into mediocrity because we keep having the human element imported or imputed?
I think that there's in robotics, traditionally the messaging has been remove the humans and things will get better, but reality holds for extremely repetitive assembly line tasks. Like for 40 going on 50 years right now, the real use of robotics has been on the assembly line, where human errors do accumulate and sometimes cause accidents for things, especially things like aircraft and medical equipment. So they're having something very repetitive is and very very automated is useful. But for what I call AI first robotics, where the robots are encountering more, like I would say, more diverse and looser scenarios that are less specified, I think having the robots be fully autonomous is going to definitely reduce. It's going to reduce for sure perceived accuracy, if not actual accuracy. Being able to interact with another human in the loop or interact with the machine in some way to refine the results is really useful in improving perceived accuracy. It's like the whole thing that makes ChatGPT tick, right? If you go take GPT-4 and you go evaluate on like a benchmark of modest difficulty that it was practically trained on, like, okay, that benchmark wasn't in the training data set, but something very like it is similar was, it's like 93% accurate, which means this computer fails 1 out of 7 tries. And you think back to all the times you use ChatGPT, probably 1 in 5 times the output is crap, but you don't notice because you just tell it, try again, do this, and like your interaction improves the perceived performance of the system. It's why fully autonomous consumer web agents, for example, have much less traction, because you feel the error rates a lot more because you have no ability to intervene. And I think it's going to be the same thing for robotics, where by having people in the loop 5-10% of the time, you're going to make the whole user experience a lot more polished. There's going to be sort of a line of defense against AI inaccuracies by having a person take over, make a decision. And more importantly, when that goes wrong, you could go interact with the system, the platform, and the people on it to try to figure out what was going on and try to improve the performance. Like having these people in the loop really, really helps tease out some of the issues that otherwise robots would face. But once again, I absolutely would not have this in manufacturing. We're having some remote guy in the Philippines come in to go remotely turn the screws on my car is an incredibly bad idea. I want a fully automated system there.
So PrismaX, we should zoom in here for a minute. Are you building robots? Are you building LLMs? Are you building like a platform that can, you're trying to become like an industry standard platform? Where do you sit in the whole ecosystem?
We basically sit where the old Scale AI sat back when Scale AI was like an awesome Python API that you could use to interact with data annotators overseas. We want to bring that level of automation to robotics builders and AI companies by letting them access trained teleoperators, data collection mechanisms, it's robots in the field through something which is very programmatic and very reliable. And the idea is by leveraging decentralization and transparent incentive mechanisms and scaling the whole thing, you can bring a sort of repeatability to these humans, which is otherwise difficult to do if you only are hiring up, say, a couple hundred people inside your company to work on these tasks. Beyond that, we do touch the hardware a little tiny bit, but mostly to sort of help the industry along. Right now, a lot of the more software-focused teams are having trouble sourcing and bringing up hardware in order to train on, and we hope that by sort of promoting a few particular embodiments as systems that you can collect data on, we can encourage a little more consistency in the industry, which will make the data sets more valuable. We don't touch the models. We work with our partners and customers to build models. Models are sort of a rat race, because as soon as you release your model, miraculously everyone else happens to be at the same. Like, you were number one by like a year until you launch. It is suddenly you were only ahead by a lot.
Yeah.
I do not know whether people are just like stealing the data from the models, or it's like people advance at the same time. But time and time again has proven the state of the art is state of the art for about 2 weeks.
I suspect that's because, like you mentioned earlier, people have been working on something for years and they see they have a competitive advantage until they don't, and then they have to rush to market. Otherwise, they're irrelevant until they spend another 2 years catching up or getting ahead again. And so who's the customer for you? What's an ideal customer look like?
We work with what we call AI native robotics companies. Like, we're one of them, but basically companies that are focused on end-to-end machine learning workflows for robotics, ideally with some sort of real world application in mind. So a little bit less of the pure play hardware vendors, a little more focused on applications. We also I think there's upcoming potential to work with some of the more incumbent industrial heavyweights, but those companies are very, very slow. They're like the double whammy of being slow industrial companies in the first place, and mostly being based out of Europe or Japan, which are not known for their fast pivoting. It takes literally years before you could get these companies to adopt new technology. So maybe a little bit further down the line, but right now it's mostly the more nimble startup type customers.
Is there an incumbent, or is there an industry standard already doing what you are doing, or is this just brand new pioneering work?
It's brand new. It's blank space, and we plan on being the industry leader in the space. To us, pure play operations data teleoperation services for robotics industry will become a big market. And because of the way we're doing, I think we have a lot of unique advantages over whoever else wants to play.
Yeah. Do you see that robotics is just going to touch every aspect of life and the globe, or is it going to be bigger in industry? Is it going to be bigger in the home? Is it going to be bigger in like defense and military applications? What do you think is, or what do you think is going to be? I mean, maybe you already mentioned industry has been first. The production line is already really that's where it's prolific at the moment. Yeah. But where do you see over the next maybe 10 or 15 years? What's going to be the biggest robotic space?
I think we're going to step into it, right? Right now, it's like pure heavy industry with repetitive workflows. We're going to slide into a lighter industry, more what I call commercial, things that you might see but are still sort of working in the back end in somewhere like a restaurant or a hotel. Then eventually closer and closer to the home, and then eventually everywhere. And I think the shift may be a little more subtle than you think it is. I don't think it's going to be like a humanoid robot's going to one day ship into your house. I think it's going to be more and more machines which are increasingly more automated and do more. Maybe even not a full 6 or 7 degrees of freedom to begin with. Maybe something like 3 to complete some tasks. But it's going to make your life better. We're still going to get better and better machines and better use cases. And I think that's really important, right? Once again, as I said earlier, tempering your expectations and selling products which work well rather than over-promising and then delivering something which doesn't do what you said it would do, I think is really important to gain trust in the industry. ChatGPT was an anomaly, and it's like no one expected, right? Not even OpenAI. And not like OpenAI did not expect that this model would be able to talk. They expected a model that could like translate English to French better. That was the previous use case of the transformer. Like it's called the transformer. It transforms sequences of words into other sequences of words. So I think trying to immediately jump for like full chat GPT on the product side may be a bad idea. I think on the R&D side, going for generalization is a good goal, but trying to ship something general ahead of when it's ready into two consumers is going to be a bad idea. I often draw this analogy. I used to do a lot of work in AR, VR, and like VR sort of overpromised and shot itself in the foot, right? Where it was a good technology. It has a lot of uses, and we're only now beginning to see the use cases mature. But they promised you the world. They promised you like everything ranging from like surgery in VR to an entire native token NFT based planet where you could buy houses and land and live in VR. And none of these things happened. It was really embarrassing. So I urge any robotics engineers listening to this and robotics founders to not go overpromise your product, please.
So at the consumer level in the home, as you're speaking, I'm thinking back to my, the purchases I've made over the last couple of years where my air fryer suddenly had Wi-Fi for some reason. And my dryer, my heat pump dryer, clothes dryer would speak to my clothes washer and they would know what to expect. And then there's some sort of, it says AI, but who can say what that is? And then I went to buy a TV recently and everything is AI TV now. And so it's more of this kind of step by step. It's not like we go from, just plug something in and turn it on to all of a sudden we've got a fully autonomous humanoid robot, but it is going to be that step by step, IoT, things will talk to each other progressively, more and more arms doing more and more things. And then one day we may or may not even need that robot, the humanoid robot. Right?
IoT is actually a really good analogy, right? Like back in like 2013, people were throwing money at IoT of smart home. It was going to be the next big thing. Then we like saw it come out of it for many years. And it just slowly crept into our lives until now everything you own, from like your coffee machine to your air fryer to your like beer mug, is all somehow connected to the internet.
Yeah. But we got to talk about military applications, defense. You mentioned, AI is a tool, robots are a tool, and they can be used to build things and can be used to break things. And for me, I tend to philosophically think about military primarily from a defensive thing, as in a good, not as but like everything, the very first iPhone I ever got, I jailbroke it. People were jailbreaking their Teslas, jailbreaking everything. And so, you get something in the home, which is made to build things and potentially being used for other things. But before we get on to that, I'm keen to ask about, what's your vibe about or feeling about military applications when it comes to robotics? Is the future we see going to be very little human involvement, or like in lots of sci-fi at the moment where there's people behind a desk in a kind of VR or AR contraption controlling a robot or a drone somewhere on the battlefield? What's your take on this? Where are we going when it comes to military applications?
I think drones are already a given. They're getting better and better, and time and time has proven that they're cheaper, and they sort of at least save lives in the air, maybe at the expense of those in the ground, for better or for worse. As far as more complex forms of robot in defense applications, depending on which side of the fence you stand on, it's either a good thing or a bad thing that the hardware is nowhere near ready for adversarial situations. They tried this in 2013 with quadrupeds, and just everything from the control algorithms to the range to the battery density just wasn't enough. And I think maybe the first defense adoption of more complex like biomimetic systems will be in exoskeletons. They're working on it. They work on it year after year, and they run into problems mostly with range, that the batteries aren't energy dense enough. But you can imagine where being able to extend the on-the-ground range of your infantry is incredibly valuable for a lot of these applications. And you don't have to worry about controls algorithms. You still get the agility of a human, but you get more strength. Like, and I think right now it's not like a sci-fi world where the man becomes 3 times stronger and can punch through walls. It's really just about fatigue and being able to carry load, right? It turns out in an actual war, as they say, like the best logistics win. So a lot of what these people are doing is carrying 50-pound backpacks from one point to another on foot. And I think that's an interesting and like decently wholesome application. It's not being used to destroy anything directly, and it's a tool. As far as defense use of AI in general, I think we're going to see increasingly sophisticated forms of high throughput reconnaissance. With like modern AI vision models, you'll be able to identify anomalies, detect things at scales you've never been able to see before. And we'll leave it to the people living in each country as to decide whether this is something they want in their own countries. Certainly looking into other people's countries is something that I think like if you live here and you want to look there, it's something reasonable. It seems to be good for the place you live. But I'm sure some countries will also want to adopt this to keep domestically. And we'll leave it to the citizens who may or may not be able to vote on this matter to decide whether they want this.
Yeah. Do you have any particular fears or concerns when it comes to AI robotics and military applications?
I'm personally not a huge fan of large scale surveillance and reconnaissance, because I think the way laws, even those in Western countries, are written is that some of them are sort of meant to be broken, right? Like things like jaywalking and speeding and all these little municipal things. And if we gain a large scale ability to monetize the enforcement of these things, it's going to create like a chaotic era of inconsistency where every time you go faster than 55 miles an hour, you automatically receive a bill, which is interesting. You basically have to pay money to get places faster, which is not a great place to live in. And I think that's going to cause a little bit of turmoil. And also, of course, there's things like bias and the technology is being used to single out individuals and more aggressively enforce penalties on them because they're opposed to the like current way of thought. I think all of these are not good things, but fundamentally that's not AI's fault, right? It's the issue is that we do have laws that are written to be broken in the places where we live. Like no one abides by the speed limit. No one like abides by the walk sign. No one takes all of their trash and puts it in a trash can every time. There's all these little like local things, and some change I think is going to happen. Like I can tell you in China they just embraced this. Like it's now you now receive an automatic fine for taking your trash out on the wrong day of the week, and they love it because they have a different, they don't have an expectation of privacy there, but they do have a lot of problems related to things like maintaining a clean city. So having draconian enforcement of these laws to force people to like keep things clean does seem to be appreciated. But different societies and different people have different expectations. I think if you received the bill every time you jaywalk, you'd get very angry very quickly.
I mean, man, I share your aversion to a surveillance state for sure. I think there are other ways maybe that we could make that work. Like you mentioned, you go over the speed limit and automatically you're getting fined. And if we're on some sort of digital dollar, it might just automatically come out of your wallet. But if you wanted to get somewhere faster and all the cars spoke to each other and you could pay your fellow commuters some money to let them get into the slow lane so you could pass them, I could see that kind of transaction.
Right, exactly. Right. It's not necessarily a bad thing if you set it up right. But to your point, having some sort of digital currency and transparency in the system and making sure that all the rules are you are always enforced is very important here. Otherwise, like what's going to happen is like people, like groups will get singled out.
Yeah, true, truly. Bayley, what is your most contrarian view? Do you have anything in particular that you always find you're having to argue or advocate for that nobody else seems to think? Everyone's looking over this way, you're looking over this way, or anything you're particularly swimming upstream on?
Contrarian views. I think that on the technical side, people should stop building better and better demos and go straight for some reasonable form of scaling, because I think that's going to be important to ship anything at all. Building these increasingly more sophisticated demonstrations of what appear to be doing like folding laundry appears to be an immensely popular field of robotics right now is not actually going to get us anywhere. It's not going to create a shippable product. So people should stop trying to build investor demos and actually sit down and think about what it takes to scale. On the more sort of, I guess, application focused side, there's I think that AI safety is a somewhat overblown thing. I think it's just a new technology, and once you actually understand that it's a statistical model of things it's seen in the past, a lot of the fears you have sort of go away. Like fundamentally, it's not conscious. It doesn't think like a person, and it doesn't really make decisions on its own. It produces things which look like what it's seen in the past and tries to predict these sequences, but it can't really come up with anything truly new. And that's sort of reasonable. Coming up with truly new things involves like complex logic, and logic is a very computationally hard problem.
So don't worry about it. Go out and build something that works.
They'll build something. It's very unlikely that you're going to, outside of biological systems, I will say, it's unlikely that like your run-of-the-mill LLM is going to cause any novel sort of damage to the world beyond like some script kiddie is going to use the LLM to generate some sort of new exploit for some e-commerce platform. But like some script kiddie would have done this anyway because the exploits existed. It's just moving the pieces around. Biological models are one thing where I am very concerned about, because it takes a preciously short sequence of RNA to create a virus that causes the end of our species.
Sure.
And perhaps we should think more before going down this path. No one's done it yet because I think people are self-preserving.
Well, I mean, hopefully.
Hopefully.
I feel like that lasts.
All it takes is one bad egg, so maybe we should keep an eye on the bad eggs.
Yeah. Is there any way
I like having the species.
I really do. Absolutely. Have good for it to last a little while.
Instinct is great.
Oh man. Now, when you advocate for those views, do you get pushback, or people generally, do they see your point?
I get a surprising amount of pushback on the generalization thing, but I think it's simply because of commercial alignments. There are a lot of companies and researchers are taking the other path and want it to remain relevant because it's what they have the resources to do as like an individual or a small team. The safety thing is sort of a split down the middle. I think there's people like me who believe that AI is really just it's a mathematical model and it's not going to create something crazy. And there's people who are very worried about it because they think it's going to have some sort of greater consciousness beyond the training data. Everyone seems to agree on the biology models thing. Like everyone agrees they should be heavily regulated if and when they hit surface.
Oh yeah. On the folding laundry thing, is that just a heuristic, or is that an unofficial benchmark that people are working towards, or are there particular benchmarks that people are using to, in the industry to prove that things better?
It's just a heuristic. It's just a heuristic for now. They do things like a number of pieces of clothing successfully folded and placed into a container, but all the clothes are different, so there's no standardization.
Yeah, okay, yeah, that's fair. That's fair. Well, Bayley, man, I really appreciate you coming on the show today, telling us a little bit more about what you're building, how you're trying to help humanity, and maybe hopefully have allayed some fears of people who are a little bit worried about AI and robotics and whatnot. If people want to find out or hear more from you and find out more about Prisma X, where can they find you online?
Yeah. You can find us at prismax.ai or follow us on X, formerly Twitter, at PrismaXAI.
Good on you. Thank you. Anything in particular you're looking forward to for the rest of this year?
Yeah. We're doing our first sort of product launch for the teleoperation platform in early mid-August. It'll be super exciting. We'll have tournaments to go find the top operators. We'll have a prize pool. You'll be able to join and play for your own community. The different big chains will be able to compete against each other. So you'll be able to see who has the twitchiest gamers, like Solana, Ethereum, or Base.
That sounds cool, man. Well, yeah, I'm looking forward to hearing more about that as well. All right. Well, thank you again, and please go check out Bayley and Prisma X.
Yeah, very cool. Thank you.
Thank you for joining us again today. Hope you enjoyed this episode of Off Chain. We love bringing you great guests like Bayley, and I hope we've inspired you to think more about AI and robotics and crypto and technology in the future, and how you might be a part of building that future. As always, please like, subscribe, or better yet, share this episode with a friend and help us spread the word. And join us again next week for another great episode of Off Chain. Till then, take care.